Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about metric interrelationships. In the metric system, there's a very nice relationship between volume and capacity. Volume will tell you how much space there is, and capacity tells you how much it will hold. So for example, volume would be measured in cubic meters or cubic decimeters or cubic centimeters, and capacity would be measured in liters or milliliters or kiloliters. So let's start with this rectangular solid. It's a cube, and it measures 1 decimeter by 1 decimeter by 1 decimeter. The volume, therefore, of this is 1 cubic decimeter. So remember, a decimeter is about the width of your hand. So if you took a container that had that as a length and width and height, you would have a cubic decimeter. The scientists that developed the metric system designed it so that that volume held a certain capacity, and that capacity is a liter. A cubic decimeter of volume holds 1 liter of liquid. This amount of water is a liter. It would fit into a container that had a volume of a cubic decimeter. And because it was designed that way on purpose, it makes it very easy to find out how many liters fit in different spaces. So if you have a volume, let's say of 5 cubic decimeters, that container has a capacity of 5 liters. If the volume is 20 cubic decimeters, the capacity is 20 liters. In addition to those two units being equal, if the substance that you're working with in terms of capacity is water, that amount of water has a mass of exactly 1 kilogram. So this amount of water will have a mass of exactly 1 kilogram. The container it's in will have a volume of a cubic decimeter. The amount of water is a liter, and the mass of that amount of water will be 1 kilogram. So again, going back to our example, if we had 5 liters of water, the mass of that water would be 5 kilograms. If we had 20 liters of water, the mass of that amount of water would be 20 kilograms. So a very nice relationship between volume and capacity, and then with water, mass. Let's make a chart and take a look at some examples. So here's our chart, or here's our relationship between volume and capacity. A cubic decimeter is equivalent to a liter. And if we're dealing with water, that amount of water has a mass of a kilogram. So there are no awkward numbers to multiply or divide by like there is in the imperial or the American system. It's just very straightforward. So if you were given the dimensions of a rectangular solid, you could very easily find what the capacity is, and if it was filled with water, what its mass is. Let's take a look. We're given the dimensions in meters of a rectangular solid. And because we want our volume in cubic decimeters, we have two options. We can either change our dimensions to decimeters before we start so that when we get a volume, it will automatically be in cubic decimeters. Or we can find our volume in cubic meters. And in the last video, we talked about how we change cubic meters to cubic decimeters. Whichever way you go about it, you should get the same result. I'll do it both ways so you can see the results are the same. So here, volume is 3 times 2 times 1 will be 6 cubic meters, which if I change from cubic meters to cubic decimeters on our volume scale, it's 1 step over to the right, so I move my decimal point 3 places. So that will be 6,000 cubic decimeters. The other option is I could change my dimensions to decimeters before I start. Remember, on our length scale, to go from meter to decimeter, it's 1 step over. So we're multiplying by 10 or moving our decimal point 1 place to the right. So this would be 30 decimeters, 20 decimeters, and this would be 10 decimeters. So if I multiply 20 times 30, that's 600, times 10, you can see that it's 6,000. So either option is fine. Now that we've got the volume in cubic decimeters, then we know the capacity of that container. 6,000 cubic decimeters would have a capacity of 6,000 liters. And if this was filled with water, the mass of that water would be 6,000 kilograms. So once you found the volume, you basically found the other values. Let's take a look at those interrelationships if our volume is in a larger or a smaller unit. So for example, let's say we went to a cubic meter. So remember, there's 1,000 cubic decimeters in a cubic meter. It's one step over, so it's 1,000 times larger. That, because it's 1,000 times larger volume, the capacity would be 1,000 times larger. And 1,000 liters is called a kiloliter. So every cubic meter of volume would hold a kiloliter of liquid. And if that liquid were water, that amount of water would have a mass of 1,000 kilograms. And 1,000 kilograms is a ton, a metric ton. So you could work with this relationship. So going back to that example, if we had worked with our volume in cubic meters, we could find the capacity and it would be in kiloliters. So if the volume is 6 cubic meters, the capacity would be 6 kiloliters. Well, we know that the volume is also equivalent to 6,000 cubic decimeters, and we know the capacity is 6,000 liters. So hopefully you can see that 6 kiloliters is equivalent to 6,000 liters. So if we have a volume of 6 cubic meters, we have a capacity of 6 kiloliters, and the mass of that water would be 6 tons. And is this mass equivalent to 6,000 kilograms? Yes, it is. So you could work with your volume either in cubic decimeters or cubic meters and just know what units are related. We could also work with a smaller unit for volume. So if we were to take a look at our volume scale, we would go from cubic meter to cubic decimeter to cubic centimeter. A cubic centimeter is 1,000th of a cubic decimeter. Or in other words, 1,000 cubic centimeters would equal 1 cubic decimeter. So therefore the capacity would be 1,000th of a liter. 1,000th of a liter is called a milliliter. So a cubic centimeter and a milliliter are exactly the same size. So if you had a space or a volume of a cubic centimeter, it would hold exactly 1 milliliter. And that amount of water would have a mass of 1,000th of a kilogram. 1,000th of a kilogram is 1 gram. So you can work with your volume in any of these 3 units, and then you can find the corresponding capacities, and if you're dealing with water, the corresponding masses. It's up to you to decide which unit you prefer. I think you'll agree that you're going to find this very useful and easy, especially compared to the American or the imperial systems.